Let's look at the proof of Pythagoras' theorem. So Pythagoras' theorem states that for any right-angled triangle, a squared plus b squared equals c squared, where c is the hypotenuse or the side opposite the right angle. So in these 5 triangles, if we first identify the hypotenuse, then we have that the side opposite the right angle in this first triangle is this side, which is the hypotenuse c. In this triangle, the side opposite the right angle is this side, which is the hypotenuse. In this triangle, the side opposite is this side. In this triangle, it's this side. And in this triangle, it's that side. So all of these sides that have been labeled as C represent the hypotenuse of each of these right-angled triangles. Now, to start off the proof, we first begin with a right-angled triangle that is labeled in the following way. And what we're going to do is we're going to draw 4 congruent right-angled triangles to form a square in the middle with side lengths C. When we say congruent triangles, we mean triangles that are the same shape and the same size as this first triangle. So if we do that, we get the following. So we've got a diagram with the 4 congruent triangles, and we can see that in the middle we've got a square with side length C. We're going to work out the area of the square in the middle, but we're going to work it out in 2 different ways. So the first way is we're going to work out the area of the outer square, and we're going to subtract the area of the 4 congruent triangles to leave us with the area of the square in the middle. So to work out the outer square area, we first need to think about what the side lengths can be represented by. So if we look at the base of the square, we have a plus b, which gives us the total side length for the base, and the perpendicular height is given by a plus b as well. And so therefore, the outer square area is equal to a plus b times a plus b, or in other words, a plus b squared. So expanding this out, we have a plus b multiplied by a plus b, which equals to, so a times a is a squared, a times b is ab, b times a is ba, or ab as well, and b times b is b squared. And if we collect like terms, we end up with a squared plus 2ab plus b squared. Now, to work out the area of the 4 triangles, we have 4 multiplied by the area of one of the triangles. And to work out the area of a triangle, we use the formula a half times base times height. So in this case, the base for this triangle is b, the height is a, and so we have a half times the base, b, times the height, a. And so this would equal to the area of the 4 triangles. If we simplify this, 4 times a half is 2, 2 times b times a is equal to 2ab. Finally, we know that the area of the inner square is equal to the area of the outer square minus the area of the 4 congruent triangles. So in this case, the area of the inner square is just c times c, which is c squared. And the area of the outer square we worked out as a squared plus 2ab plus b squared. So we can write that in. And then we're subtracting the area of the 4 congruent triangles, which we worked out as 2ab. So minus 2ab. And so we see that positive 2ab and negative 2ab cancel. And so we're left with c squared equals to a squared plus b squared, which in other words can be written as a squared plus b squared equals to c squared. And we've proved Pythagoras' theorem.